Hey everyone, welcome back to your math class, and today we're going to be talking about triangles. So we're going to take some of the information that we learned in our lesson about polygons and some of what we learned in our lesson about angles in the last lesson, and today we're going to combine those ideas together in our lesson about triangles. Now you will see today I'm recording from the car, so sorry if the audio is not perfect. Hopefully it's not too much worse than usual. Hopefully it's not better than usual because that would be pretty bad. But yeah, so today we're going to be talking about triangles. If you see any like changes in setup in my location, that's just because I'm in the car right now, but I might not be in the car for the entire time that I'm recording this lesson. But anyway, let's get right into it. So the plan for today's lesson is we're going to start out with a review of the different types of angles, which we talked about in the last lesson. And then we're going to jump into talking about triangles in two different ways. First, we're going to classify them, so we're going to group them together according to how many angles and sides of equal size they have. So how many angles that triangles have that are exactly the same size, and how many sides are of equal length. So we'll look at it that way first. We'll talk about triangles that have all three sides are exactly the same length and all three angles are exactly the same size, uh, versus triangles where only two of the sides are the same length and only two of the angles are equal, versus triangles that don't have any sides that are the same length and don't have any angles that are the same size as each other. So we'll talk about that first, and then we'll also talk about classifying triangles according to the types of angles that we see in the triangle. So that'll come after our review of the different types of angles, and then we'll see, there are some triangles where you see this type of angle and some triangles where you see that type of angle, and we will explore that way of classifying triangles as well. So first things first, we're going to review the different types of angles. So this is what we saw in the last lesson. I've just lifted the exact same picture and put it here as well. So we're really only going to be focusing on those top three: acute, right, and obtuse angles. So acute angles are those that are smaller than 90 degrees. So anywhere from here out to there. And then once you reach that point, that's a right angle. That's a 90-degree angle. That's like a quarter turn. So from here, or rather if I, show it like this is a quarter turn, right? A quarter of turning the whole way around. And that is a 90-degree angle. That's a right angle. And then an obtuse angle is anything bigger than that up to when you get a straight angle right here. But we're not going to be really concerned with straight angles for most of this unit. So we're mostly going to be talking about acute angles, right angles, and obtuse angles. Those are the only ones that are going to really come up a lot in this unit. There might be the occasional straight angle or reflex angle that comes up later, but you won't really need to worry about the terminology for those. So those are the three kinds of angles. I don't want to spend too long on that because we already talked about those in the last lesson. So yeah, now we're going to jump into the different ways that we classify triangles. So there are two main ways that we classify triangles. To classify means to kind of group them together when they share the same quality or the same property. So for instance, among all the shapes, among all the polygons, you can group all the three-sided polygons together and call them triangles. That's any polygon with three sides is called a triangle. So triangles are already, you've taken all of polygons and then you're saying, okay, this group of the polygons, these ones all have three sides, we'll call those triangles. These ones all have four sides, we'll call those quadrilaterals. These ones have five sides, we'll call them pentagons, right? So we've already done that little bit of classification before, a couple of lessons ago. And now we're looking within the triangles, how many different, kinds of triangles are there? How many different ways can we talk about triangles? And we'll see this as well with quadrilaterals, right? Because we already know, for instance, the difference between a square and a rectangle. They're both quadrilaterals. They're both four-sided shapes. They've both got two sets of parallel sides. We'll talk about that later. They've both got four right angles, right? They got a lot of properties in common, but there are some differences between your square and your typical rectangle, right? So you already understand some of these differences in classification, maybe without even realizing it. But what we're going to do today is we're going to explore that same kind of idea, but we're going to do it for triangles. So the first way that you can classify triangles is by how many equal sides and equal angles a triangle has. So for instance, if I just draw a little triangle on here, um, something like this, right? So there's three possibilities. You could have that all three sides are different lengths, right? So something like if I draw those in, if I say, okay, this one is a different length from this one, which is a different length from this one, right? So I've put like one tick in that, two ticks in the next one, and three ticks in the third one to show that they're all different lengths from each other. So that's one option, that all three sides are different lengths. And in this case, when all three sides would be different lengths, then all three angles would also be different lengths. But it's also possible that you have a triangle where two sides are the same length as one another. So for instance, if I were to say something like that, now I'm saying that this side here and this side here are the same length as each other. So that's what the double tick marks being here and here indicates, is that this side and this side are supposed to be the same length. And in that case, if you had those two angles, if you had those two sides be the same length, then you would also have that these two angles are the same size as each other. So that's a second possibility. And then your third possibility is that all three sides are the same length. So that would look something like this. So one tick mark in each of those sides means that all three sides are the same length. And in that case, all three angles would also be the same size. So those are the three different options, right? When you've got a three-sided shape, you could have that they're all the same size as each other. You could have that two of them are the same size as each other, but the third side is a bit longer or a bit shorter. Or you could have that, yeah, you could have all three sides are the same. You could have all the two sides are the same as each other, or you could have that all three sides are completely different, right? So those are the three different options. And if you've got three sides that are the same length as each other, it just happens to be, and we could explore this in greater detail if you guys like, but it happens to be the case that if all three sides are the same length, then all three angles are also going to be the same size as each other. If two of the sides are the same length, then two of the angles are going to be the same size as each other. And if all three sides are different lengths, then all three angles will also be different. So that's the first way to classify triangles, and we're going to look at them in more detail on the next slide. But the other way is by the types of angles. So the types of angles that we just looked at on the previous slide, so the acute, right, and obtuse angles. So every triangle has at least two acute angles, two angles that are smaller than 90 degrees. So if I draw a triangle, just any triangle, something like this, right? Something like that. Every triangle is going to have at least two acute angles. So in this case, this one, definitely an acute angle, smaller than 90 degrees. This one, also an acute angle, smaller than 90 degrees. But this third one up here, this one, it could be an acute angle. If you change the drawing of the triangle a little bit, maybe it's a right angle. If you change the drawing a little bit more, maybe it's an obtuse angle. And so we can classify the triangles based on whether or not we have all acute angles, or if we've got two acute angles and then one right angle up here, or two acute angles and one obtuse angle up here. So now let's jump into looking at each of these in more detail and with some more diagrams. So here we've got three different types of triangles, and the differences are how many equal sides, how many sides of equal length, and how many angles of equal size we have between them. So the three types, the first one on the left, this is called an equilateral triangle. So that's one that's got three equal sides and three equal angles. So we could indicate that it's got three equal sides by putting a tick mark here, a tick mark here, and a tick mark down here. So that says that even if it's drawn a little bit wrong, all three sides are supposed to be the exact same length. So this is useful because if I were to tell you, you know, I have a garden and it's the shape of an equilateral triangle and the side length of one of the sides is 6 meters, then because I've told you it's an equilateral triangle, you automatically know that if one side is 6 meters, then the second side is also going to be 6 meters, and so is the third side. So this is where it starts kind of being useful, but we'll explore that a little bit more in future lessons. For now, I just want you to understand what the differences are, and then we will apply that knowledge to problems going forward. So equilateral triangles, all three sides are the same length and all three angles are the same size as each other. So like that, that, and that. Those are all the same, those angles are all the same size. And because in a triangle, if you add up all three angles on the inside of a triangle, it always adds up to 180 degrees. So that means that each of these is going to be 1/3 of that. So all three angles in an equilateral triangle are always 60 degrees. That's not 600, that's 60 with the little degree sign, right? So that's what an equilateral triangle is. Then we've got in the middle here, we've got this weird looking word, but it's pronounced isosceles. So an isosceles triangle is one which has two sides that are the same length as each other. So in this case, that's this side here and this side here are the same length as each other. And then this one is a different length. So I'll put a different number of tick marks. So we put 2 tick marks down there. So we've got two sides that are the same length, right? That's this side here and this side here are the same length as one another. And then this side here is a different length from both of them. Now, in an isosceles triangle, this side, you don't have to like memorize this right now, but I'll just tell you that if you want to find the two, let me go back. For an isosceles triangle, you have two sides that are the same length as each other. That also means that you have two angles that are the same size as each other. And to figure out which two sides which two angles those are, they're always the angles that are touching the side that's a different length. So I'll just show you here. So you don't have to memorize this. If it's confusing, just ignore it. All you really need to know for an isosceles triangle right now is that they have two sides that are the same length. But if you want to know a little bit more, if they've got two sides that are the same length, they also have two angles that are the same size as each other. And those two angles will both be the angles that are touching that side of the triangle that's a different length. So these are the two sides that are the same length as each other. This is the side that's a different length from the other two, and these are the two angles in this case that are the same size as each other. So if I were to draw a different triangle, something like this, right? And I told you this side and this side are the same length. That means that this side over here is a different length, so I put a different number of tick marks. And it's the two angles that are touching that different side that are the same size as each other. So in this case, it would be those two angles right there. And then the last option is the scalene triangle. So that's one where all three sides are different lengths and all three angles are different sizes. So we could put that in with different tick marks. So 1 tick mark here, 2 tick marks here, and 3 tick marks down here to show that it's 3 different lengths for the 3 different sides, and then all 3 angles would be different as well. So that's one way that we can group the triangles into different categories depending on how many equal sides and equal angles that they have. Now you'll never have a triangle that's got 3 equal sides but only 2 equal angles, or 2 equal sides and 3 equal angles, or 3 equal sides and no equal angles. If they've got 3 equal sides, they've got 3 equal angles. 2 equal sides, 2 equal angles, no equal sides, no equal angles. That part makes it a little bit easier. So that's how you classify triangles, by equal sides. Now you can also classify triangles by the types of angles that you find inside them. So I already said this before, but you're guaranteed to have two acute angles in every triangle, no matter what. So for instance, well, I'll show you in a sec, but so the three different types of triangles when you're going by the types of angles is you can have an acute triangle. So we already heard about acute angles, right angles, and obtuse angles, but you can have an acute triangle if all three angles are acute angles, like so. You can have a right triangle if you have a right angle. So that's this angle right in here. That's a right angle. So that makes it, so if you have a right angle in your triangle, you have a right triangle. And then if you have an obtuse angle in your triangle, you have an obtuse triangle. So what I'll show you as well is you're guaranteed to always have at least two acute angles. So in the right triangle, the acute angles are here and here. In the obtuse triangle, the acute angles are here and here. And in the acute triangle, they're all acute angles. So basically, you've got an acute triangle if you've got all acute angles. You've got a right triangle if you've got two acute angles and one right angle. That's the important part. And you've got an obtuse triangle if you've got two acute angles and one obtuse angle. Again, that's the important part. That's where the name of that type of triangle comes from. Now, the interesting thing is you can actually combine these two types of classifications as well, and you can talk about triangles in a little bit more detail. For instance, if I tell you that this side here is the same length as this side here, then you know that this angle and this angle are the same size as each other. This side is a different length from the other two. And so all of a sudden, this thing looks familiar to what we saw on the previous slide, right? We've got two sides that are the same length as each other. That's an isosceles triangle, right? So you could describe this as an isosceles triangle, or you could describe it as a right triangle because it's got that right angle. So you could actually call this thing a right isosceles triangle. So it's kind of cool that you can combine these two different methods of classifying triangles. For instance, same thing over with the obtuse one. I don't think they're the same length, but if I were to say that this and this are the same length as each other, and this is a different length, then again, we've got, oh, this is a triangle with two sides that are the same length as each other, one side that's a different length. This must be an isosceles triangle. But instead of having a right angle in the middle like we had over here, we've got an obtuse angle. So this would be an obtuse isosceles triangle. This would be a right isosceles triangle. So it's kind of cool that you can mix and match the different types of ways of classifying triangles, and kind of smush them together and come up with this way of talking about triangles with a little bit more information. Now, a bit of a heads up is that equilateral triangles all have the exact same shape. So they always look exactly like the blue triangle that's on the screen. They might be bigger, they might be smaller, they might be turned a little bit to their side, but they're always the exact same shape. If you could just turn them and then make them bigger or smaller, you would get that they're all exactly the same shape as each other. But this is not necessarily the case for the other two types. So we had equilateral, isosceles, and scalene triangles. So this is only true for equilateral triangles, but for isosceles and scalene triangles, they can look very different and they can have different types of angles, like I showed you sort of on the previous slide with like the two sort of examples of isosceles triangles. But now let's look at them in more detail, because for an isosceles triangle, you could have that all the angles are acute angles, you could have one right angle, or you could have one obtuse angle. And same thing for scalene triangles. So I'm going to show you an example of an acute isosceles triangle, an obtuse isosceles triangle, and a right isosceles triangle. So you can see that they're all isosceles triangles. They've all got two sides that are the same length and one side that's not. But you're going to see that the angles are different types of angles. One's got all acute angles, one's got a right angle, one's got an obtuse angle. And I'm going to show you that on the next slide. So here we go. We've got three different types of isosceles triangles, and these are all actually isosceles triangles. So the sides are all actually, the ones that are supposed to be the same length really are. So in this first one, this side here and this side here are the same length as each other. So those are the two sides that are of equal length. This one is a different length. So that makes it an isosceles triangle. The second one, this side here and this side here are the same length, and this one is a different length, so that makes it an isosceles triangle. And for this one here, this side and this side are the same length, and this one over here is a different length, so it's an isosceles triangle. But in this first one, this is an acute angle, it's smaller than 90 degrees. This is an acute angle, and this is an acute angle. So because they're all acute angles, this is an acute isosceles triangle. In the second one, this is an acute angle, this is an acute angle, but this is an obtuse angle up here. So that makes this an obtuse isosceles triangle. And then this last one on the right, this up here is an acute angle, this down here is an acute angle, but this one in the middle is a right angle. So we draw in that little square. And so that makes it a right isosceles triangle. So here you can see that they're all isosceles triangles, but one of them's got all acute angles, one of them's got two acute angles and an obtuse angle, and one of them's got two acute angles and a right angle. Now, because these are isosceles triangles, you could also figure out, if you remember this from a couple of slides ago, if it didn't confuse you, that this angle and this angle will be the same size as each other. This angle and this angle will be the same size as each other. And same thing for this angle and this angle will be the same size as each other. Because for an isosceles triangle, if you've got two sides that are the same length, because that's what you need for it to be an isosceles triangle, you're also going to have that two of the angles are the same. And for an obtuse triangle or a right triangle, it's easy to see which one is the obtuse angle, which one is the right angle. So it's going to be the other two angles. But for an acute isosceles triangle, it can be a little bit trickier to figure it out just because they're all acute angles. But that's why I said before that it's the two angles that are touching that one side that's a different length from the other two. So I hope that makes sense. These are the three different kinds of isosceles triangles. Now let's look at the three different types of scalene triangles. So here we go. Now we've got three different types of scalene triangles. So in this first one, we've got three different sides that are three different lengths, like so. So I could put in different tick marks, right? Different numbers of tick marks. In the second one, same thing. We got three sides of three different lengths. And same thing over here. We got this side, we got this super short side, and then we got the longest side over here. So we got three sides, three different lengths. And that means that all the angles are going to be different sizes as well. But in the first triangle, the one on the left, this over here is an acute angle. This over here is an acute angle. And this over here is also an acute angle. So this becomes an acute scalene triangle. It's an acute triangle because all the angles are acute angles. And it's a scalene triangle because all the sides are different lengths and all the angles are different sizes. The second one, all the sides are different lengths. So that's what makes it a scalene triangle. All the angles are going to be different as well. But this up here is an obtuse angle. And so even though the other two, this one here and this one here, are acute angles, because we've got that obtuse angle up at the top, that makes this an obtuse scalene triangle. So obtuse because we got the one obtuse angle, and scalene because all the sides are different lengths and all the angles are different sizes. And then same idea for this last one over here. We've got a right scalene triangle. So we got three sides, three different lengths. So we're going to have three angles of different sizes as well. But that one on the top is an acute angle. This one over here is an acute angle, but this one here is a right angle. So because of that right angle, we've got a right scalene, right? Right angle because, or sorry, right scalene because we've got a right angle right here, and scalene because all the sides are different lengths and all the angles are different sizes. So here's a sort of professional summary of the different types of triangles. So you can talk about them in terms of the sides on the left side. Um, so three sides that are all equal in length to each other, and you can see that with the tick marks, and all the angles are also the same as each other. That's an equilateral triangle. But if it's not all three sides, but only two of them that are the same size, and only two of the angles that are the same size, then that is an isosceles triangle. And if you've got no equal sides and no equal angles, so three sides that are all different lengths, three angles that are all different sizes, then that's a scalene triangle. And for the types of triangles by angle, the right half, you've got a right triangle if you've got one right angle anywhere in there. So that's this one right here is a right angle. You've got an acute triangle if all three angles are acute angles. And you've got an obtuse triangle if you've got one obtuse angle. So one angle that's bigger than 90 degrees, bigger than a right angle. So those are the different types of triangles. Now I'm going to show you in one picture all the different triangles that we've looked at today, and then we will pretty much be done for this lesson. So here are all the triangles that we looked at today. I've color-coded them a little bit differently so you can see how they're grouped together. So we've got an equilateral triangle up here. So that's one where all three sides are the same length and all three angles are the same size. They're all 60 degrees. So that's an equilateral triangle, and it's by itself because there's nothing you can do to an equilateral triangle besides like turn it over on its side or make it a little bit bigger. It's going to still be the same shape. But you can see that these triangles over here, they look different from one another, right? And it's not just that one's like turned over from another one or a little bit bigger or smaller. They're actually different because this one on the left doesn't have any right or obtuse angles. It's all acute angles on this one. But this one has a right angle down in this corner. Down in this corner. And this one up here has an obtuse angle up there, but the one on the left just has three acute angles. So they're genuinely different triangles from each other, and you would have to like redraw them to get them to look the same as each other. You can't just like turn these over or make them bigger or smaller to make them look like the rest. You have to, they're actually fundamentally different triangles. And then same thing with these three orange ones at the bottom. Those are our scalene triangles. Again, over here we've got three acute angles. And then over on the next one, we've got this obtuse angle up here. So that makes it different from the acute one, right? And then this one down here, we've got a right angle in there. So we can see the differences between these triangles as well. And so these are all the triangles that we've looked at, and these are all the triangles that there are, basically. And yeah, so going forward in the next few lessons, we will start to do some problems. Maybe we'll look at quadrilaterals first, four-sided shapes, and how to talk about those and their differences. But at some point very soon, we will start talking about, we'll start doing some problems that involve understanding these differences and similarities between the different types of triangles. So like I already told you before, I could give you a problem that's about an equilateral triangle. So you know that all three sides are the same length as each other. And then I only tell you something about one of the sides. I only tell you that, oh, you know, in my backyard, there's I made a little sandcastle and it's got a triangular base. And this, you know, the side length of the base of my little sandcastle is 20 centimeters, right? And then I tell you to find what's the total distance going all the way around the base, right? What's the distance going all the way around here? And you'll be like, well, you know, you only gave me information about one of the sides. I can't solve the problem because you didn't give me information about the other two. But I did because I told you that all the sides are the same length. And I won't use those words, right? I'm not going to say, oh, all the sides are the same length. I'm going to say the base is an equilateral triangle. And that's supposed to tell you, oh, all the sides are the same length and all the angles are 60 degrees. So it might not make complete sense right now how this can be useful, where this can be useful, but we're going to get into some interesting problems where we're going to have to use these properties of these different types of triangles, the different qualities that these triangles have, to actually solve the problems. So um, yeah, we'll talk a little bit about quadrilaterals first, I think, and then we'll start to get into some questions where you have to figure out things like the distance going all the way around the side of the triangle, where I haven't necessarily given you all the information, right? And then we'll get into word problems, things like, I've got a sandcastle in my backyard, or I got a garden, or whatever, and then I'll tell you, oh, my garden is a right scalene triangle, right? Figure this information out for me. So it's going to be cool. It's going to be fun. Geometry is an awesome unit, and triangles are very cool. And get comfortable with them, because if we've got time going into the last few weeks of the school year, we're going to try and do a trigonometry unit. And trigonometry is so much fun, and it's all about using triangles, and particularly right triangles. So right isosceles triangles and right scalene triangles, we're going to get very comfortable with if we get to do our trigonometry unit. So that is everything that I've got for you guys today. It might be a little bit shorter than what most of my lessons tend to be. I didn't mean for it to be that way. The car is actually not really an impact to that at all. It's just this is all the material I really wanted to cover in this lesson. I could talk for an extra 5 minutes, but I don't think you guys need that. You may as well just enjoy the last few minutes of class if you've got some time. And for those of you that might be interested in the chess club that I was talking about, I will hopefully have more details ready about that very soon. As always, if you have any questions, let me know. I do have a bit of a busy week ahead, but I will try to be at least checking for your questions when I get a chance. And yeah, let me know if you need any help, or if there's anything that hasn't made sense in these first few lessons of the geometry unit. But if I don't hear from you, then I will see you all in the next video. Have a good one.